One.
In class, the last couple of days, we've been discussing statistical questions. We've been looking at measures of center like mean, median, and mode, and how to find each of them. We have also looked at different types of graphs like bar graphs, line graphs, histograms, box plots, and pie charts, and we also now know how to create them. But sometimes graphs can be misleading, and today we're going to learn how to recognize misleading graphs. Today's learning target is I will be able to identify when a data display is misleading. But first, let's talk about why it is important to know when data displayed is misleading. For one instance, it's for you to make your best judgment on that piece of data that is being advertised. An example that I've found is a company using a misleading tidbit is Trident Gum. Take a look for yourself to see if you can find this misleading information from 1984.
It doesn't taste like sugarless gum.
Tastes so good.
Trident sugarless gum has long-lasting flavor.
Taste the one.
I get a good, fresh, clean taste, and it doesn't hurt my teeth.
Taste the one that'll win you over. The sugarless gum.
4 out of 5 dentists surveyed recommend sugarless gum for their patients who chew gum.
With Trident sugarless gum, I've got the best of both worlds.
Taste the one that'll win you over. The sugarless gum.
It's good gum.
Did anybody catch that little tidbit that could be misleading? Yes, the 4 out of 5 dentists approve this product is misleading. But why is that misleading? We don't know how many dentists were surveyed in Trident's survey. So that is very misleading. So let's look at what to look for in a graph or a chart that could be misleading. Anytime you see an unequal interval on the scale doesn't start at 0, or when we're comparing different amounts. And I'll show you some examples of these pretty soon. Now let's first take a look at a bar graph. If you look at this bar graph, we're looking at school population. Our y-axis is talking about the number of students, and we're comparing boys and girls population of the 6th, 7th, and 8th grade. So just by looking at the graph, why might this graph be misleading? The graph does not start at 0, therefore it is misleading. So what might people believe from this graph? Well, the 8th grade fills up the whole chart. So that's this proportion for the whole school. So it looks like the 8th grade has more of a population. That's why it's misleading. On the next slide, we're comparing 3 different companies, graph A, graph B, graph C, and we're comparing their sales with creamy and crispy bars. Just by looking at it, not analyzing your X and Y axes, I look at graph A and assume that they sold the most candy bars. Graph B looks like they sold the least. But if you look close at the scales of our y-axis, graph C has the correct scale. It starts at 0, goes all the way to 6. The interval on graph A goes from 0 to 3, and the interval for B starts at 3 and goes to 5. So the intervals for graph A and B are incorrect. Graph A does start at 0 though, but if you look really close, you will notice that all 3 graphs showed the same amount of bars. The creamy bars, each company sold 4 million in sales, while they sold 3.5 of crispy bars in sales. So if you didn't look at the graphs, you wouldn't know that it's misleading, and it would automatically assume that graph A shows that they sold the most candy bars. All right, let's take a look at a line graph. This is a school event attendance. We're looking at soccer, the darker line, and the dashed line is lacrosse. What might make this graph misleading? There is a break between the data, but the data goes from 0 to 50. Now, would that make a difference? Well, let's take a look, for example, at the month of April. If I look at the month of April and look at lacrosse, lacrosse had 55 attendees at their game. Soccer had 75. If you look at the graph, though, it looks like soccer had many more than 20 people attending their game. So this graph is misleading because of the break in the data. All right. So next, we're going to do a group activity, taking what we just learned. The first part of this activity, we're going to find a partner. When the timer hits 0, you're going to find that partner, give them a high five, and you're going to answer a 3-part question. After 2 minutes, you and your partner will discuss your answers together, and we will share out as a whole class. We will repeat until all the questions have been answered on the board. Here's your first graph. Your first graph is, question is, what type of graph is this? Why is this graph misleading? And what might we think when we are comparing both graphs? So again, remember, we're looking for what type of graph this is, why might it be misleading, and what do we think we're comparing both graphs? Here we have a pictogram of Halloween candy collected, and I want you to ask yourselves, why is this graph misleading? And what might we think when we look at this graph? So I want you and your partner to discuss that. Here we're looking at tickets sold, a football game, ticket sales, and the months. So why is this graph misleading? And what type of graph is this? And what might we think when looking at this graph? So again, we're looking for those 3 things when looking at misleading graphs. Unequal intervals. Does a scale start at 0? And are we comparing different amounts? So that's what you and your partner need to be discussing when determining if the graph is misleading. Here's another graph talking about football games won. So we have 2 high school, Grant High School and Lee High School, talking about games won. So why is this graph misleading? What might we think about this graph as is? Here we're comparing two things. Graph A, we're talking about favorite places to visit. Graph B, same thing, favorite place to visit. So we're looking at a zoo, a beach, a park, and a museum. Which graph appears to favor the zoo as the favorite place to visit? So we're comparing the zoo. What is the actual difference between graph A and graph B for the zoo? So again, let's look at our scales. Let's look at our interview, and what are the graphs trying to tell us? So to save a little time, I'm going to go ahead and get to our exit slip. So closure. How can data display be misleading? Look at the scale to determine if the intervals are equal. Look at the scale to see if it starts at 0. If there is a break in the data, is it representative of the amount? When comparing two graphs, are they comparing the same criteria?